Hello class, today we are going to talk about inscribed angles and polygons. These are angles and polygons that are inscribed inside a circle. So with an inscribed angle, what we have is an angle whose vertex is on the circle and whose sides contain chords of the circle. So both the sides of the angle go through the circle, go all the way through there. An arc that lies in between the sides of the angle is called the intercepted arc. And the arc is said to subtend the angle. If the endpoints of the chord or the arc are on the angle, and then it is said to subtend the angle. So arc AC subtends angle B, chord AC also subtends angle C. Angle B, and angle B intercepts arc AC. So the measure of an inscribed angle will always be equal to 1/2 the measure of its intercepted arc. So here we have angle D is inscribed in the circle because its vertex is on the circle and the sides go through the circle, and it intersects arc AB. And so the measure of angle D is 1/2 the measure of arc AB. So let's put this into use here. We need to find the measure of angle T and the measure of arc QR. Well, let's start with angle T. So look at angle T and see that it is inscribed in the circle and that its intercepted arc is arc RS. So that means the measure of angle T is 1/2 the measure of arc RS. So it's 1/2 of 48, which is 24 degrees. So the measure of angle T is 24 degrees. Now we also need to find the measure of arc QR. Now QR, we notice there's no angles or anything for QR, so we're going to have to think of something else. However, we do have this angle right here, angle R, which it hooks up with intercepts arc QT, and QT and QR make up a semicircle because this is our diameter. So that means that QR and QT are going to add up together to be 180 degrees. So if we can find QT, we can get QR. Well, QT is the intercepted arc for angle R. So that means angle R is 1/2 of the measure of angle QT, so 50 times 2 is 100 degrees. So the measure of angle QT is 100 degrees. And then we can, since this is a semicircle, we can subtract that from 180, and the measure of arc QR is going to be 80 degrees. And so that's not too bad. Now what we're going to do here is find the measure of arc RS, and then we're going to find the measure of angle STR. So arc RS is right here, and it has two intercepted arcs. We're given this two inscribed angles that intercept that arc, and we're given angle U, and the measure of angle U is 31 degrees. So RS is going to be twice 31 degrees. So the measure of angle of arc RS is 62 degrees. 2 times 31. Now we need to find the measure of angle STR. So angle T over here. Well, angle STR intercepts arc RS, so it's going to be 1/2 the measure of arc RS. So that was 62. 1/2 of 62 is 31. So what do you notice about angle STR and angle RUS? Well, this one's 31 degrees. And that one also we just calculated is 31 degrees. So they're both at 31 degrees. They're congruent. They have the same angle measure. And they also intercepted the same arc. All right? And that's kind of interesting. It's interesting enough that they gave us a theorem about it. The inscribed angles of a circle theorem. And what this says is that if two inscribed angles of a circle intercept the same arc, the angles are congruent. So since angle D and angle C both intercept arc AB, these two angles are going to be congruent. Also on here, angle A is going to be congruent to angle B because they both intercept arc DC. So, nice easy question for us. We want to find we're told the measure of angle E is 75 degrees. We need to find the measure of angle F. Well, if you look, angle E intercepts arc GH, angle F intercepts arc GH. They both intercept the same arc, so they have the same angle. So angle F is going to be 75 degrees by the inscribed angles of a circle theorem. All right. So what I would like you to do is solve these three questions, pause the video, work them out, and then come check your work. All right, let's see how you did. Number one, the intercepted arc is 90 degrees, so the angle is going to be half of 90, it's 45. Number two, the intercepted arc is what we're looking for. The inscribed angle is 38 degrees, so we're going to take that and double it to get the arc. So 38 times 2 is 76. And here, both of our inscribed angles intercept the same arc ZW, and so they are going to be congruent. So y is 72, x is also 72 degrees. All right, so nice, easy stuff. Now let's take a look at inscribed polygons. An inscribed polygon is where all of the vertices of a polygon are on the circle. And so the polygon is said to be inscribed. Inscribed, that means drawn inside. And the circle is circumscribed. Scribe means to draw, circle means to go around. So this is drawn around the polygon. All right. Now, what we can do with this, we've got two things. First, right triangles. An inscribed right triangle. Well, if a triangle is inscribed in a circle, if it's a right triangle inscribed in a circle, then the hypotenuse will be the diameter of the circle. Also, if you have an inscribed triangle and one side is the diameter, then the triangle will be a right triangle, and the side opposite the diameter is a right angle. Okay? And if you think about that, looking with what we just saw with inscribed angles, if this is 90 degrees, then the intercepted arc is 180 degrees, which is a semicircle. And so this has to be the diameter. All right? And if this is a diameter, then this must be 180 degrees, and angle B must be half of that, so 90 degrees. So you got your right triangle there. All right. Inscribed quadrilateral theorem. What this says is that the only way you can inscribe a quadrilateral in a circle is if opposite angles are supplementary. All right? So that means that since this quadrilateral is inscribed in a circle, angle E and angle G are supplementary, so they add up to 180 degrees. Angle F and angle D are supplementary, and they'll add up to 180 degrees. All right? So let's take a look at this, see what we can do with it. So we need to find the value of each variable. We're looking at our circle here in our triangle. We see that segment AB goes through it's a chord, it goes to the center of the circle, so it must be a diameter. So since this is a diameter, our triangle must be a right triangle. And the angle opposite that diameter is the right angle, so 2x must be 90 degrees. And if 2x is 90 degrees, divide by 2, x is 45. All right? On problem B, we have a quadrilateral inscribed in the circle, and so the opposite angles have to be supplementary. All right? So that means that angle D plus angle F has to add up to 180. So Z plus 80 is 180 degrees. Subtract 80 from both sides, Z is 100. Same thing is going to be true about G and E. All right? So G plus E is 180 degrees, so Y plus 120, subtract 120 from both sides, and Y equals 60. All right? So that's nice stuff, not real hard. All right? Easy stuff. So what I want you to do is solve these three problems. Solve for each of the variables. You've got 2 variables in each one. Pause the video, work these out, and then come back and check your work. All right, let's see how you did. Number 4, Well, MK is a diameter because it goes through the center, so that means this is a right triangle. And it also means that X must be the 90-degree angle. That's your right angle. Now, if that's 90 degrees, then that means the other two angles must be complementary because they're acute angles of a right triangle. So Y is 90 minus 40, and so Y is 50 degrees. Number 5, we've got a quadrilateral inscribed in a circle, so opposite angles must be supplementary. So for X, X plus 82, because that's angle B plus angle D, equals 180. Subtract 82 from both sides, X is 98. Same thing for Y. Y must be supplementary with the 68 degrees. So we subtract both sides from 68, and we have Y equals 112. Number 6, slightly more complicated, only because we have expressions and not just straight up numbers. Still, same thing we did on number 5. C is opposite the 2C minus 6, angle S and angle U, so they must be supplementary. So C plus 2C minus 6 equals 180. Combine like terms, so add 6 to both sides, divide by 3, and C is 62 degrees. All right. T and V are opposites, so they must be supplementary. So their measures, 8x plus 10x is 180. Combine like terms, divide by 18, and x equals 10. All right, so that was nice and simple. Inscribed angles, inscribed polygons. An important thing to remember, an inscribed angle is half the measure of its intercepted arc. A right triangle will always have the diameter. An inscribed right triangle will always have the diameter as the hypotenuse. Again, it has to be a right triangle. If it's not a right triangle, then it will have some other angle as the hypotenuse. It won't have the diameter. There won't be a hypotenuse, obviously. And an inscribed quadrilateral has to have opposite angles supplementary. If the opposite angles aren't supplementary, then the quadrilateral can't be inscribed in the circle. And that's it. I hope you found that helpful, and I'll catch you next time.